Welcome back, Legacy Savers. Today we're going to continue on section 2.5. What you're going to want to make sure you have is, of course, your notebook, writing utensil, and you may want a calculator, but most likely you will not need it today. So what are you going to look at? Today we're going to look at solving more literal equations. One of the big things that we're going to shove in today is we're going to see also how to plug in values once we solve it, which is pretty easy, but I just wanted to let you guys see an example of that too. Here's some steps to solving literal equations. You do not need to write these down. First of all, like we've been doing, we want to identify where the equation the variable is. So if they want x, we're going to always circle it or make sure we know where x is. And then we're going to begin solving for that variable like you would do if the other variables were numbers. So this is similar to what we did last time we watched a video. So let's take a look at this example. You are going to want to write this one. So they asked me to solve the equation 4 equals 2m minus 5n for m. And then they say, what are the values of m when n equals -2, 0, and 2? So what I'm going to make sure I do first is I want to write down my equation. And they say they want m. So I'm going to circle m so I don't lose him in the muck. So to begin solving for m, I need to get rid of whatever's not even attached to m. I noticed that I had this -5n hanging out over here. So I'm going to get rid of him on both sides. I'm going to add him. That way I can get 2m all alone. So on the left I'm going to get 5n plus 4, and on the right I get 2m, because these guys are going to cancel out. Now, I need m alone, remember, so I'm going to circle him. So I got to get rid of this 2. So right now this is 2 times m, so I'm going to divide by 2 on both sides. I'm going to get 5n plus 4 divided by 2 has to equal m. So I got done with my first part. I solved the equation for m. Now they want to know what is m if I plug in -2, 0, or 2. So over here I'm going to squiggle my line here just so I have an example. And then I'm going to say when n equals -2. So I'm going to go 5 times -2, because that's where my n is, right? And they say n equals -2. I'm going to add 4, and I'm going to divide that by 2. So now I got to do some math. So I got 5 times -2, and that's going to give me a -10. I'm going to add 4, and still divide by 2. Can't forget about him. Now, -10 plus 4, if you need to use a calculator, that's fine. We notice that's -6. So I got to divide by 2. Now, -6 divided by 2 gives me 3. And a negative divided by a positive is going to give me that -3. So m equals -3 when n is -2. Now they want 2 more values, so I got to see when n is 0, what do I get? So I'm going to go 5 times 0 plus 4 divided by 2. 5 times 0 is going to give me 0. Plus 4 there. 0 plus 4, 4 divided by 2. And 4 divided by 2 is 2. One more value left. N equals 2. So I'm going to plug in a 2 where n is, divided by 2. So I got 5 times 2, 10 plus 4, divide that by 2. 10 plus 4 will give me 14. Keep that divided by 2 going on. 14 divided by 2 is going to give me 7. So I found when n equals -2, m is going to equal -3. If I have 0 for n, I'm going to get 2 for m. If I have 2 for n, I'm going to get 7 for m. Let's take another look at an example like this. So they want me to solve the equation x minus 4y equals -4 when I have y. And then they want me to plug in some values for x. Oh, this should say y right there. That should say y. So you're going to want to also write this one down. So I got x minus 4y equals -4. They want me to solve for y, so I'm going to circle y. Make sure I don't lose them. So I'm going to get rid of whatever's not attached to this -4y. So I notice I have this positive x right here. So I'm going to subtract from x on both sides. So this is going to cancel out because I got positive x and negative x. That gives me 0 x's. -4y. Now I'm going to have negative x minus 4 on this side. Got to divide by that -4. So I get y equals -x minus 4 divided by a -4. So I've solved for y. That's all as far as I need to go. But they want to know when x equals -2, what do I get for y? So I'm going to plug in -2 there. Now you need to be very careful because there are some negatives galore on this one. Alright, so I have a negative and a negative. Remember, that's always going to give you positive. So actually, I'm going to have on the top 2 minus 4 divided by -4. 2 minus 4 gives me a -2. And this is going to give me -2 divided by -4. If you try that on your calculator, you will get a 1/2, or you'll get 0.5 if you try it on your calculator. Alright, now, if I plug in 4 for x, I will get, so I get -4 minus 4. You see how I just put that 4 in parentheses? That way I can kind of see what I've plugged in. -4 minus 4 is going to give me a -8 over 4. Oh, almost forgot my negative. -8 divided by -4 will give me a +2. Circle my answers here so I can see what's going on. Then they want to know, what about x equals 6? So I'm going to plug in that 6. So I got -6 minus 4 all over -4. So -6 minus 4 gives me a -10. -4. Now a negative and a negative gives me a positive. And then I can simplify 10 over 4. Both of them can be divided by 2. So I'm going to get 5 over 2 for an answer, which is also the same as 2 1/2. But I'm okay with having the improper. If you want to have the improper fraction, that's fine. Now, definitely make sure this one gets down in your notes, because this one for a fact these are the harder kind of problems that we're going to see today. So they want to see, what equation do you get when you solve ax minus bx equals c for x? So they want x alone. So I noticed something. I have 2 x's, which is kind of weird. I can't get x alone, because if I add that, then I'm going to have this, and it's just going to be a whole big mess. Now, if you remember the distributive property, if you remember when we looked at our properties, the rainbow effect, a lot of you called it. What that looked like was like this. You guys remember? Now, what we have on this problem, we have this right-hand side right here. We got the same variable with 2 different variables. So what we can do is we can actually go from the right-hand side and go to the left. So we can actually, in essence, we can yank out that a. In our case, we're going to yank out the x. So I'm going to take that x, I'm going to yank it out. Divide by x on both of these. And yank him out of our equation. I want to make sure I put But that is the distributive property that allowed me to do this, just for future reference. So I yanked out that x because they both had common x. And I wanted x, just a single x. I don't want two x's, I just want one x. So I gotta yank him out. Now, I needed x alone. If I remember right, x, when I have a variable right beside parentheses, that means multiplication, if you guys remember that. So I need to get x alone, so I'm going to break this multiplication. And the opposite of multiplication is division. So I'm just going to divide everything by a minus b. You can actually divide, because a minus b is just some number once I would plug in some values. So a minus b and a minus b, that's going to cancel each other out. So I'm going to be left with x on that side. And I'm going to have c over a minus b. And that is my answer. So the key to these kinds of problems, when you want a variable and you have double of that variable, you need to use this distributive property to be able to pull it out or yank it out. We're going to look at factoring later in the year, and that's technically what you're doing. Let's look at one more example like this. So they want, from this equation, they want us to pull out x. This here, right here. Please find x. So I need to yank out that x from this side. So I got, if I yank that out, m plus 2n. That still equals p on this side. Now, I need x alone, if you remember that. So right here I had two x's. I'm going to get x alone. So, just like last time, this was multiplication before. So I'm actually going to divide by whatever is multiplied. So I'm going to divide by this entire thing right here. So I'm going to divide by m plus 2n on both sides. So I'm going to get, so that's going to cancel, I'm going to get x equals p divided by m plus 2n. Done. Because x is alone, and that's all they wanted. They wanted me to solve for x. Now here's an actual problem when you're actually going to use this. So they say a monarch butterfly is the only butterfly that migrates annually north and south. The distance that particular monarch butterfly travels is 1,700 miles. That's a lot of miles. It takes a typical butterfly about 120 days to travel one way. So that's just getting from the north to the south one time. What is the average rate at which a butterfly travels in miles per day? So we're going to use the formula distance equals rate times, there's times there, time. So we're going to use distance equals rate times time. Now, they want to know the rate. Right here, they say, what's the average rate? So I'm first going to solve for rate, or my r. So I said that this is time, so I'm going to divide by t so I can get my r alone. So remember, that's what we're looking for. And we're going to get distance over time equals rate. Now I'm going to plug in what they gave me. So they say the distance, right here, is 1,700 miles. So I got 1,700 for my d. And they say my time. So it takes 120 days. So it's a lot of days for this monarch to travel. So 1,700 divided by 120, and that's going to give me my rate. How fast is this butterfly actually going per day? So if I divide that, and if you try it in your calculator, you'll get roughly 14 miles per day for this butterfly that he flies. You're going to get some decimals, but I just wanted to round to the nearest mile. And that's the end of the video tonight. Thanks for watching. See you tomorrow in class.